Hey everyone, welcome to Insights by Rish. In this video, we will try to understand stemming and lemmatization in detail. Now, stemming and lemmatization are one of the core concepts in natural language processing domain. In every text processing step of NLP, stemming and lemmatization are performed. Stemming and lemmatization have a very thin line of difference between them. We will try to understand that in this video. We will also understand what's the need of both of these concepts. So, let's begin with the video. This is the agenda for the video. We will first discuss the need of stemming and lemmatization. Why do we need them? Then we will discuss the core concepts of stemming and lemmatization. We will try to understand the significant difference between stemming and lemmatization. Although initially you will find both of the concepts are very similar to each other, but they still hold a key difference between them. Then we will also discuss about libraries, which are NLTK, Natural Language Toolkit, and SpaCy. Both of them are interchangeably used in NLP domain. We will understand which library to use when and what features every library provide. And at the end, we will also discuss how we will customize the lemmatization. Now, beginning with, we will understand what's the need of stemming and lemmatization. For that, you need to know what do you mean by stemming and lemmatization. Basically, both of them mean the same thing, which means converting the word to its base word. By that, what I mean is, if you have a word running, then its base word would be run. If you have a word adjustment, then its base word would be adjust. So any word which is converted into its base word, that process is called as stemming. Also, it is called as lemmatization. We will try to discuss what's the thin line of difference between both of this in the later part of the video. Now, beginning with, we'll understand the need of stemming and lemmatization. Let us consider this data set. This data set is related to a video game recently published online, and the owner of the video game wants to analyze the reviews of the user for that. So he have just gathered all the tweets that the users have made related to that video game, and now he want to analyze what are the reviews of the user, whether they are appreciating the game or whether they didn't like it, or are they facing any issues in that. So to analyze that, they have collected tweets of many people along with their username, and they have stored it in a data set. Now to analyze that, here you can see we have two columns, username and the tweet. Now, these are the tweets, and depending upon the tweets, they are going to analyze the review of the user. Generally, you don't go through all the tweet, you don't go through the entire text of the tweet to analyze the sentiments. You just pick up some specific important words depending upon which you can map the emotions of the user. And for that, you need the process of stemming and lemmatization. Let us check the first tweet. _Tina27 is the username, and the tweet is made in this fashion: this new game has been amazing, love this graphics. The second tweet is facing a lot of glitch while playing, when are they fixing? So these are all the tweets. Now, in order to analyze what are the reviews of the user, what are the sentiments of the user, whether they are appreciating the game or they are facing any issues, in that case, we aren't going through the entire tweet. We will just pick up some specific words depending upon which we will try to understand the emotion of the user or the idea behind what the user is trying to say. Now, if you check at all the tweets, let us consider the first one. This new game has been amazing. We don't require this entire line. The specific word here is amazing, because the word amazing itself embraces all the emotions of the user, that the user loved the game. Similarly, in love the graphics, we don't require the word graphics. The love itself is what we want. So these are some specific words depending upon which we are able to analyze the intuitions, or you can say the emotions of the user. In the second tweet, facing a lot of glitch while playing, when are they fixing? Now again, we don't require the entire text here. We are just require the word glitch. Now wherever you will find the word glitch, you will understand that the user is portraying some issue related to the glitch of the game. So these are some specific words which we will pick up from the text in order to analyze the sentiments of the user. So one thing you can observe here, the same word with the same emotions are written in different patterns. In the first tweet, you can find the word amazing. Now in the fourth tweet, again the game amazed me. Both the words are same. Both the words are traced back to its same root. They are just written in a different form. Similarly, another word you can find is, here you have advertisement. The user is making some issue related to the advertisement. A lot of advertisement are involved in the game. And the last tweet again involves the word advertising. Now both of the word hold same emotion, same context, just they are written in a different form. So here you can see a single word is written in so many different forms. So what you are going to do, you are going to collect all these words and you are going to store them into some bag of words that is called as BOW. It is called as BOW, which is bag of words. In that bag of words, you store the word along with its frequency occurred, which means if you consider this data set and you have a word amazed, that word amazed, amazing and amazed, these are the two words, but the core idea behind both of the words is same, that is amaze. So in that case, you will trace that both the words back to their root form, which is amaze, and you will find the frequency of that word in this data set. For example, the amaze word occurred 2 times in the form of amazing and amazed, which means the frequency of amaze word is 2. In similar fashion, the advertisement and advertising, these are the two different words written in a different fashion, but they hold the same core meaning. In that case, you will trace the both words back to their root form, which is advertise, and you will find the frequency of that word in this data set, which is 2, advertising and advertisement. Then you will again store the word advertise along with its frequency 2. So in this thing where you are storing the word along with its frequency is called as bag of words. So you will create a bag of words out of this data set to analyze the sentiments of the user. Moving to the next slide, you can find this is the bag of words. The amaze word has occurred 2 times. Now, explicitly the amaze word isn't present anywhere in this data set, but the form of it is present. The form of amaze, like amazing or amazed, a similar context of both the words written in a different fashion. So here, in order to, because if you consider both the words differently, if you start considering all these words separately, in that case your bag of words will increase its length, increase in size, and in that case it will be a very hectic and time consuming job. So in order to assume or in order to analyze the sentiments of the user, you don't consider all these words that are having the same context separately. You trace all that words back to its base form and you analyze the frequency of that word. Similarly, if you consider the second word glitch, the word glitch has occurred thrice in this data set. The first one you can find it here in the second tweet, then it's present in the fourth tweet as well, and in the last tweet where it is present in some different form, glitching. So the same word but it's in a different form, glitch and glitching. Both of it trace back to a single same word, which is glitch. So the word glitch has occurred 3 times. So the frequency of glitch word is 3. Similar way, advertise word has occurred twice in the form of advertisement and advertising. And the love, which is the loved. The base form of loved is love. Similar, we have one more word here, cool game. The cool itself is the base form. So these two words have occurred only once and they have the frequency 1. This is your bag of words where you are storing the word along with its frequency. Now in this case, if you would have considered the words differently or separately, like amazing and another one was amazed, in that case a single word would have resulted into 2. Similarly, in a glitch, if you have considered the word separately, like glitch and glitching, it again would have been resulted into 2 different columns. In that case, your bag of word would increase in size and it would be a very hectic job to do the analysis. So the first thing you are going to do is when you analyze this bag of words, first let us understand, when you analyze this bag of words, you can find the highest frequency is of the glitch word. That is, the word glitch has occurred in the data set on a very large basis. So you can easily analyze that the user are mostly having some negative sentiments about the video game and the issue is related to the glitch, followed by the word amaze, which is having the frequency 2, and advertise, which is having the frequency 2. So the owner or the organization can easily analyze that though the users are loving the game, but still the word glitch has occurred on a large basis in the dataset, which means the users are facing the issues related to some kind of glitch in the video game and we need to improve that. So instead of analyzing this whole tweets and going through all these tweets, so in this data set we have only included the 5 tweets, but in the real time data set it might happen it consists of 1 lakh rows. In that case you are not going to analyze all the 1 lakh rows. So in that case you are going to create a bag of words in which you will extract only some specific words and store it in its base form along with its frequency, and depending upon that bag of words you can easily analyze the sentiments of the user or the reviews from the user. In a similar fashion, how we analyzed looking at this bag of word that the user is facing some issue related to glitch, and apart from that the user is loving the video game. Also we need to reduce some advertisement because the issue is again related with the advertisement as well, and apart from that there is no issue, users are loving it. So if you improve on these two aspects of the game, the video game might be a huge success. So instead of analyzing this whole tweets line by line, which will be a very hectic job, this bag of words reduced your job or reduced your time. So that's why you require stemming and lemmatization process, because whenever you want to create a bag of words, you are going to store the words in the form of its base words. You are not going to store the actual form of words that were present in the tweet. You are going to convert that specific word into its base form, and then you are going to store it along with its frequency. That's why you require the stemming and lemmatization process. Now I hope that you all have got an idea why we require stemming and lemmatization. Moving ahead, we will understand what do you mean by stemming. Now I think that you all might have got an idea that what we mean by stemming and lemmatization. But again I'll tell here, the stemming means converting the word to their root forms or base forms by removing their suffixes. These base forms are also called as stem. The base form or the root words are also called as stem. Example, the original word is running and its stem word is run. The original word is adjustment and its stem word is adjust. Now, one thing you need to keep in mind, it is a kind of note, that whenever you are performing stemming using the NLTK library, it's not 100% efficient. You might face some errors and some incorrect words. Many times it results into some incorrect words, but that's fine because you don't have any other alternative to that library. You need to prefer that library only, NLTK one. So that's why you don't be 100% reliable on that library, because many times it results into some incorrect or inefficient words. Let us understand the working of stemming by implementation. Beginning with, here we will try to understand initially only on the small data. Let us consider you have some data like this. You have some words like eating, then running. You might have some words like talks and adjustment or adjustable. These are your words. This is a very small scale data which I have considered for an example. Let me zoom it. Fine. So this is a very small scale data which I have considered. Now we are going to convert these words into their stem form. For that we will import NLTK library. NLTK stands for Natural Language Toolkit. After that we are going to import the Porter Stemmer module from this NLTK library. From NLTK.stem, you will import the Porter Stemmer library. Now you have to create the object of this Porter Stemmer module. You can name that object anything. I am naming it obj object. The object is of Porter Stemmer module. So this is the object. Now we are going to write a for loop. So for I in data. Data is the list of words, this words. So for I in data, we are going to print the word which is the I, or we can also name it as word, which will be very easy to understand. For word in data, you will print the word and then you will separate it with an arrow. After that you are going to use the object that you have created, that object dot the stem form of your word. Just print that. So as you can see here, the arrow was the separator that we have given, and the original word was 8. Okay. Yeah. So the original word was eating, which got converted into eat. Running got converted into run. Talks got converted into talk, and adjustable got converted into adjust. Now, fortunately, we haven't got any incorrect word here, but that doesn't mean that it doesn't consist of any incorrect word. It do consist. It consists of a lot of incorrect translations and incorrect conversions. So NLTK library is not 100% reliable, but we don't have any alternative for this because we have another library SpaCy, but it doesn't consist of any support for the stemming function. So hence we need to prefer the NLTK library for stemming purpose. Now this is what you have performed the stemming on a small scale data. This was your data in a kind of list form. And one thing you will observe here, that the list, the words were individually present here. It wasn't a sentence. Because if it is a sentence, then you need to convert that sentence into this separate individual words, which are called as tokens, and then you can perform stemming on that. So this was stemming on the list. Let us understand how we will perform the stemming on a data set. Let us consider that you have some data set. So I will import it using pandas. Let us name the dataset df. We will load that. It is a CSV file. This is the path on which my CSV file is stored, and we will just display the first 5 rows of the data frame. This is our data frame, and here you can see this is actually the data frame for classifying whether the message or whether the SMS is ham or spam, the spam or the ham, which is your regular one. This is the data set where you are identifying whether the SMS is spam or ham. 1 stands for spam and 0 stands for ham, that is your regular message. So here again, to analyze that, we don't require this entire SMS. We extract some specific words from each SMS. We create a bag of words. We analyze that in a spam kind of message, which word is repeating on a larger basis, and in a regular SMS, which kind of words are repeating on a larger basis. Then whenever you will receive a new SMS, your model or a system will easily analyze that this particular word which was repeating on a large basis is present in this message. So this message would be classified as spam or ham respectively. So to do so, now that we have performed the stemming function on this data, here you can see the data was already present in the form of tokens. Tokens means you are converting your sentence into individual words. Consider this first sentence, which is go until some point. So this go until, this should be a separate words in order to perform stemming upon that. So here the data we considered was already in the form of tokens. In here, in order to perform the stemming function on this data set, first we need to convert this data into tokens, and let us do that using again the NLTK library. So from NLTK dot tokenize, you will import the word tokenizer. There are 2 kinds of tokenizer, the word tokenizer and the sentence tokenizer. You will import the word tokenize. Then you will create a function for tokenizing, which is a tokenizer. You will receive a text in this function, and this text will be nothing but our SMS. Then you will return the word tokenize, which is then function from this library, word tokenize of this text. I think, yeah. If now that we have created this function, we are going to apply this function upon this SMS column of the dataset. So let us do that. We will add a new column named as tokens into this dataset, which will consider the tokens of this SMS column, and then we will apply the function that we created, tokenizer, upon this SMS column of dataset. Let us check the dataset again. We will display the first 5 rows. Here you can see initially the sentence was present in an entire actual sentence form, but now every word is separated by a comma, which means now the sentence is converted into tokens, or you can say individual words. So before performing the stemming function on any data set, first you need to convert that data into tokens. And this is one of the, you can say, disadvantage of using NLTK library, because when you prefer SpaCy library, which is not available for stemming purpose, but it is available for lemmatization. There you don't need to explicitly convert the sentences into tokens. It does that implicitly, and you just go and perform lemmatization upon that. So these are the tokens, and now you will perform the stemming upon this. So you already have created the object here, which is your stemmer object. You can say object is equal to porter stemmer. This same object we will use for performing stemming again. If you want, you can create a different object as well. So we'll again write a function stemming, which will receive a text, and the text will be this tokens, the new column that we have created, the tokens. Then we will create a stem list. We will write this in a form of a list comprehension. So the object dot stem of our word for word in text. So what we are doing here, the object dot stem of word is similar to what we have did here. Object dot stem of word, the word in data, which means first it will extract the word eating here, and the word will be eating. In that case, it will convert that word into the stem. So object stem of eating would be eat. Similarly, we are doing it here, and we are doing it in a form of list comprehension. So you are taking the object dot stem of a word for word in text, and text is nothing but your tokens, which we will provide it when you are calling the function. And then, as you can see here, when you were individually applying the stem function on this individual words, you see that every word along with its stem words is written in a different row. They aren't written on a same row or on a same line in a same line. They are written on a different line. So here we want all the stem words to be present in a same single line as the tokens are. So for that, we will join it. So we will return the words. Wherever it will be a space, that you can see the after the words there is a space, and then new words are appended. So wherever there is a space, we will join it. We will join our stem list. Now that we have created the function, we will apply it on the tokens column of the dataset. We will create a new column named stem, and we will apply, and we will store all the stem words into that one. We will apply this function, apply stemming. Now when you display the dataset, let us display the first 5 rows. Here you can see the words are converted into its stem forms. For example, let's check the row second. Here you had joking in the tokens, and now the stem word is joke. Similarly, okay, here I can show you one thing. It consists of lot of incorrect words. For entry in the third row, for entry it has converted it into something like this, which doesn't make any sense, ENTRI. So for already in the fourth row, it have again converted into some misspelling error. So as I said previously, this is not a very efficient library, but as you don't have any other alternative for that, you still continue using the same. So this is how you perform the stemming on the dataset. Initially, when you are performing the stemming function only on a list of words, for an example, in that case you can directly perform the stemming function or the stem technique. But when you are performing it on a dataset, you need to first explicitly convert that text into tokens, and then you can perform the stemming upon that tokens. So this was for the stemming. Now going back to the PPT, as I said about the stemming, the next thing is lemmatization. Converting the words to their root words, or you can say base forms, by removing their suffixes. Now you will find that lemmatization, the definition of lemmatization, is very similar to what we seen in stemming, and we will discuss the key difference that we have in both these techniques in a later slide. First we will understand the lemmatization as well by implementation. So let's go back to the coding part. Now we will again consider. Now as here you can see that we perform the stemming function using the NLTK library, natural language toolkit. But for lemmatization, we will prefer SpaCy. Actually, we prefer SpaCy for everything because it's an efficient one. But as I said previously, the stemming function is not present, or there is no support for the stemming in SpaCy library. That's why we need to somehow prefer the NLTK one. So let's try the lemmatization first on some sample data, a very small sample data. So for that, first we will import the SpaCy. After that, you need to create a pipeline of NLP or a pipeline of SpaCy. For that, you will write some variable here, NLP. The word, it can be anything, any word here. I have just named it NLP. Then you will write SpaCy dot load, and you will load the pipeline, which is N. N is for English, N core web, SM, which is small. EN stands for English and SM stands for small. This is the pipeline that we have loaded. We will run that. Now that it has successfully loaded, the next thing we will do, we will consider some sample data. Consider the sample data is in this form. The sentence is 8, eating, walking, knives. Here you can see a difference that when we were performing the stemming on this sample stem data, the sample stem data, I wrote it in a form of individual words by separating them with a comma and in a list fashion. But here, while providing a sample data, I am writing it inside an NLP function into which we loaded the SpaCy pipeline, and I am writing it in a form of a sentence and not in a form of individual words. This is because in SpaCy we don't need to explicitly convert the statements into tokens. We can directly perform the lemmatization upon the sentence. The SpaCy converts the words into tokens in the background. If in this sample data I would have been provided a sentence, in that case, first we would have been need to convert that sentences into tokens and then it into the stems. So for that easy example purpose, I didn't mention any sentence here, but we tried that on a data set. Now coming back to the lemmatization part, this is the sentence and we need to perform the lemmatization upon this. As you can see, the sentence should always be given into this variable into which you have loaded the SpaCy pipeline. After that, let us again write a function, not a function, just a for loop. For word in doc. Doc is in which you have this sentence. So for word in doc, you will print the word separated by an arrow, and then you will display its root word, which is word dot lemma. Lemma is the root word or the base word in lemmatization, and stem is the root or base word in the stemming process. Now when you run that, you can find that the original words are converted into its stem words. 8. What was that? Oh, my bad. It's eating. Yeah, eating into eat, walking into walk, and knives into knife. So this is how the lemmatization is done on the small. I showed you just a small example on a very specific data, but let us now try understanding how the lemmatization works on a data set. We'll again load the same data set. I will copy this path. We are again loading this data set, and let us check the first 5 rows. These are the first 5 rows. Now, in order to perform the lemmatization upon this, as I said previously, we don't need to explicitly convert the sentences, this SMS, into tokens when you are using the SpaCy library. You can directly perform lemmatization, and the SpaCy will convert the sentences into tokens in the background itself. So we will write a function which is def lemmatization, and we will pass a text into it, which will be our SMS column. Then in this example, we saw that we are applying this NLP. NLP is a variable into which I have loaded my SpaCy pipeline, and we are applying this NLP upon every sentence. Now here, in order to apply the NLP upon every text, that is on every SMS of every row, we will write something like this: doc is equal to NLP upon this text. Doc is equal to NLP and text, and text will be the row. In every iteration it will be a different row. After that, we will create a lemma list similar to what we have created in the stem list. So here we will write word. This is again a list comprehension. Word dot lemma for word in doc. What is this? This is a list comprehension, and for word in doc, firstly the sentence, consider the first row. The first row or the first SMS for the first text will be loaded here in the first iteration in the doc variable, and then we will extract individual words from the first text which is present in the doc, and we will convert that words into its base form or the root form or the lemma. And then again, as you know, it returns word on different rows, and we need it on a single row, so we will join it. We'll join the lemma list. Now that we have created the function, now that we have created the function, we will apply it on the SMS column. So we will create a new column first, lemma, which will store all the lemmatized words, and we will apply that function on the SMS column. Apply lemmatization. It will take some time. Okay, so now that we have run it successfully, let's display the first 5 rows. As you can see here, every word now in the lemma column is in a form of a base word. So let me show you an example. In the last row here the word is lives in the SMS column, while in the lemma column we have eliminated the suffix, and now it is live. This. So this is how you convert the words into its base words using the stemming and lemmatization. Also, I shown you with the both aspects, performing stemming and lemmatization on the some sample data present in a list and on the data set as well. Now coming back to the PPT, now that we have seen stemming and lemmatization, till this extent you might feel both are similar. There's no difference, but actually it holds some difference, and we will understand that. The key difference between the stemming and lemmatization is the context. The stemming doesn't consider the context of a sentence. It randomly converts the word into its base form without considering the context of a sentence. Or when you're performing the sentence tokenization, then it doesn't consider the context of a paragraph. But in the lemmatization technique, considers the context of the word while converting it into its base form. Consider this example. I will also show you. When you're performing the stemming word, if you give some original word 8, now when you give something, some words like this, running, or some words like something like talks, these words are merely in the form of base words if you extract their suffix part. As you can see the talk, if you remove this suffix s, you will easily get the base word. Similarly in the running, if you remove this nig suffix, it will be in the base form. So the words are merely present in their base forms if you extract the suffix. That case, the stemming words works perfectly. But when you have some words that need to be grammatically transformed into their base word, in that case stemming doesn't work, but the lemmatization do work. Now consider the word 8. Now this is not a kind of word where you will remove the suffix and you will get your base word. No, here you need to grammatically convert the word into its base form. So the stemming is incapable of doing so. When you are doing that with the help of stemming, you can see the original word is 8 and the stem word, which is the converted word, is again 8. So the stemming is incapable of transforming the words grammatically. But when you consider the lemmatization, the original word is 8 and it successfully converts that word into 8. So such kind of words or such kind of specific lines where you can see the stemming doesn't work but the lemmatization does. So in this case, whenever I think you are performing any NLP related task, you mostly prefer performing lemmatization instead of stemming, because lemmatization involves all of the stemming part, but stemming doesn't involve all of the lemmatization part. That is, the lemmatization includes whatever the stemming does, the lemmatization includes, as well as it includes some original features as well, but the vice versa is not true. So that's why lemmatization is the most preferred one, as it's also accurate and it also has the capability to grammatically transform words. That was the key difference between stemming and lemmatization. If you want to check that live, I can show you here. This was for the stemming, and let me include the word 8 here. Instead of running, I will write it 8. Now when you are running your stemming library, you can see the 8 is 8 only. It hasn't converted into 8. 8 is still 8. While I will show you here in using SpaCy. Here you can see, okay, I have already shown you. In this sentence, when you use SpaCy to perform the lemmatization, the 8 was successfully converted into 8. That's the difference. That's the difference where your stemming is incapable of and lemmatization is capable of. Now, moving ahead, as I think I already talked a lot on the NLTK and SpaCy library. So these are the two most popular library used for any NLP related task in a NLP core domain. NLTK, that is the Natural Language Toolkit, and the SpaCy library. There are some some aspects like stemming where the SpaCy doesn't support that features. So that's why you need to use NLTK. You don't have any other option. But if you check preference wise, then SpaCy is the most popular one as it's efficient. Again, the use of library purely depends upon the kind of data that you have and the kind of model that you want to build and the kind of working that you want at the end of the output, at the end of the deployment. So the use of library purely depends upon that. If you talk about personal preference, the using SpaCy is always efficient and handy, as it reduces your task manually, and you need to do it reduces your task, like as I shown here. You don't need to explicitly convert the sentences into tokens using SpaCy, but when you are using NLTK, you need to do that. So it kind of increases your work while the SpaCy kind of reduces your work. But again, both libraries have their own advantages and disadvantages. So there's no standard parameter that when to use what. It purely depends upon the kind of work you are doing. But these both libraries are used interchangeably. Now moving ahead, I think the last agenda that we had, we completed all this first 5 things. The last agenda that we had was to customizing the lemmatization. Now coming back to the code, we will understand this through the code, because there is no theoretical part there. Now as you can see here, we had some words like here, ate, eating, walking, knives, and we got them converted into their root forms. But this was only possible because in the library they already stored the words along with their root words. But what about the man-made slangs? Man-made slangs, like let us consider this example. Doc is equal to NLP. NLP is a variable into which you have loaded your pipeline. Now consider some words like bro, brother, brotha, brew, and broski. Now these are no formal or standard words. These are just random informal slangs developed by humans for their loved ones. So this library doesn't hold any root word for this one. If you try to convert this into its root form, let us do that for word in doc, and let us try to print the word along with its base form separated with an arrow. You can see, okay, sorry, I didn't run that. You can see that the words are again converted to the same words, because the library doesn't hold the base forms for any man-made slangs developed by the humans. It only holds the base words for the formal words that are present in the dictionary as well. In such case, when you want to customize your lemmatization, when you want to give the base words for your own words, in that case you need to customize your lemmatization, and for that you will use one of the NLP pipeline, that is your attribute ruler. Let's see how you do that. Okay. Let's say X is your variable into which you are loading one of the NLP pipe. This is get pipe, and you will get the attribute ruler pipe, which is attribute ruler. This is your pipe. Now we will add this words and we will name the root word for this. So the x dot add, just add these root words. The first text that you are adding is the word bro. Fine. The second text that you are adding is the word, I think it was brotha. The third word that you are adding is brew, and the fourth word that you are adding is broski. So these are the words for which you want to name formal base word for this, and so in here you will write a comma. The lemma word would be brother. All this translates informally to brother, so you want that base word to be brother. Now when you run this, so that's successfully run. Now when you again run this particular code, which initially translated every word back to its own form, now when you will again run this, again the doc and this, you can find now every word translates to a common base word brother. So this was the way by which you manually customized your lemmatization to add your own words into it and map it into some base word which is provided by again you. So this is how you can customize your lemmatization in but again this concept is used in a very rare case. That was just for information. So I think all the agendas are covered, and we have covered everything about stemming and lemmatization using the NLTK and SpaCy library. So that's it for the video. Thanks for watching.